Hello everyone, my name is Argham Mukherjee. I am pursuing MSc in Machine Learning and AI from LJMU. Through this video, I would try to cover my dissertation topic, which is caption the real-world images to provide visual insights. So the main motivation behind this project is that in day-to-day scenario, we face a lot of real-world problems. Like for an example, if I talk about visual impacts or visual impaired people like blind people, so they have a lot of trouble going through their day-to-day journey, and there can be scenarios where say they uh, encounter accidents or probably they suffer from a lot of problems. Some problems can be like probably not able to read the cross signboards or maybe any placards or any specific roadblocks which they can come across. So through this research, I would try to understand the scenarios and try to find a solution which can probably give some people a better life and also facilitate in achieving our narration towards any visual scenario, like it can be an image or a video, through multiple steps of process and algorithms used in this research. So the main questions what lie here is that what is the possibility of the research post captioning? Like, can the frames be understood in a better way? Whatever frames we derive, how meaningful are they? Can this solution be scaled up to a deployable environment, maybe a production environment like a software or a hardware equipment or any that kind of scenario? And what is the scope of this caption? Like, till where can we get the realistic understanding and the narration of the concepts? So I have done a couple of literature review through multiple papers, and some of them is what I have mentioned here. So while going through the papers, I understood that there are multiple approaches what people have taken, and some of them can be like, for an example, increasing the accuracy of the result. Some of them have tried to understand that if suppose there are not enough captions, then how to go forward with that. In some scenarios, people have tried to do multiple understanding, like probably cleaning the data, cleaning the data set as well as the images, and then captioning those with multiple alterations and all. So these are the overall understanding which we get from this literature review. Taking you through the methodology. So for this research of mine, I have used Microsoft MSCOCO dataset. And for fetching this dataset, I have used API calls. And those are provided from the like the documentation of Microsoft, where we have test, train, and validation data separately. There are also annotations which are pre-annotated with related to that data, and it has like image to text pairing with indexing, and multiple segregations are there which are stored in some JSON format, and images are stored in JPEG format and other formats as well. So I have also shared the link of the data set from where I fetched. It's from the MSCOCO data set using the MSCOCO API. So for my project understanding, I would be taking the video as a sample and creating step by step, frame by frame images. Then using that image, I will try to generate captions, and with that caption, I will try to create audio narration for that, and would be saving it to an MP3 format, and so that we can collate multiple narrations and try to create a storytelling concept. So if I talk about the overview of the structure, this is how it looks like. It basically uh, conveys that we are using the high level video, which is for my understanding, I have taken it as an MP4 royalty free video, which has to be extracted frame by frame. Then I'm leading it to the caption process, and after captioning, I'm using it for the audio conversion, and with that I am creating a solution where we can use it for our narrative. So this is the step-by-step algorithm of video to image conversion. So as I mentioned, we are using MP4 format video, and we are using OpenCV, which is in background using computer vision, and we have multiple functions like video capture and all, where we're starting from frame 0 till the level it is required, and we are extracting frame by frame by frame, and then we are checking continuously whatever amount of video is left to extract, and accordingly we are trying to get the data that okay, this is what it is, and probably this is the remaining part, and accordingly we are looping through it. And once everything is done, we at the end we destroy whatever temporary processing has been done, and we release the video for our next steps. So this is a sample video what I am going through, and I would like to give some insights here. So we see that there is a boy who is flying a kite, and we see some scenarios like greenery, sky, clouds, mountains, and the visually like we can also see a person standing in the background. We also see some flares from the sun which is falling into the lenses. And if you see this part, so this is the last frame where the person is holding his hand this way and just trying to go out of the frame. So that is the end of the frame here conversion. Now this is how the images are extracted. So on the left hand side, if you see, so I have given a screenshot where I have tried to elaborate the framing mechanism, and it is stored in step by step format, which is from 0 till the sequential order till the time it completes the video. After that, this is a sample demonstration. So at the first frame, we see that the entire object what we have seen in the video is present. And then if we see towards the left side of the last frame, so here we see that the person is exiting from the frame. So just to give an understanding how frame by frame extraction is done. This is one more example where we are trying to understand that exactly how things scale up. And like here we see a kitchen, we see a refrigerator, we see sink and stove, and there are some cupboards and everything. So this kind of images are broken down into pixel by pixel, and we try to visualize and understand what can be the narratives of this caption. So for this, I am using beam search algorithm. So without beam search algorithm, we are just probably getting single narrative. But when we are going through beam search algorithm, we are getting multiple narratives. Like if you see here, so we have three options, which is like some gives an insight of a dishwasher, stove and everything, and others give some partial insight. So based on the results, what we derive, we can understand and try to conclude whatever narration we want to use from that. So here would be the same caption what we generated, and I would like to parse through the audio here. So this is how it would look like, and
A
this is the
kitchen with a
audio.
refrigerator, sink and stove.
So now going to the conclusions part. So my end goal was to achieve and understand that, okay, what is the feasibility, what can we do. So in this scenario, like for an example here, I am trying to understand, and I am trying to get an insight of real world scenarios which can solve some problems, like probably a dangerous situation, maybe a firearm, or maybe a weapon which is being pointed to some person who is not able to see. It can be also a possibility where we're trying to create a better storytelling impact. Like if suppose there is a person who is watching a video and probably wants to get better insights, maybe has problem with his eyesight or color blindness or any sort of that issue. It can also resolve some issues like probably crime, where we can set up a software which will uh, directly capture the live video and also remove all the unnecessary things and then try to create a narrative. One more example can be like if we try to integrate this with a self-driving car software, where the camera lenses will capture the video real time, parse it through, and also create narrative. So it can give like an alarm if a person is driving for long hours, and if the person is about to fall asleep, so then it can provide a haptic feedback or anything as such. One different aspect can be into gaming, where we can use VR or AR streaming into real-time scenarios and provide sequential feedbacks again, which gives a realistic experience, and it has a future scope where we can explore. So to conclude here, my contributions would be here to fetch the data through API calls, which is MSCOCO dataset, which I have already mentioned before. And I am using CNN encoder and RNN decoder, converting videos frame by frame and storing it into image format, and then using that for captioning. And once we receive the caption, those captions are redirected to get an audio output, and which can further be used for narrations. So as a part of future work, like what I understand is that if we can create a framework or maybe bundle up with a deployment solution, so we can host it in multiple servers. It can be through microservices, it can be through cloud services, through APIs, as well as we can integrate to hardwares, like for an example, voice assistant or a earpiece. So if suppose I give a scenario where we consider like a blind person who is not able to say uh, understand, or maybe not able to get some insight, so we can like probably stream a real time video and give them a narration. Or if there is a child who is blind from probably from birth, and the person has never seen the life, so this can probably complement and add some functionalities which will give them a better experience, and might be something which people would appreciate, and they would at least have a better life. That is the whole agenda behind it. So this will be all from my side. I would be sharing the links of the video over Google Drive as well as YouTube, and I would also upload this document here. And I would be more than happy to work on any feedback which you have for me. That would be all from my side. Thank you.